Hi. Okay, so this is the second part of the introductory lecture where we're just going to cover the syllabus, and what we have left to cover are the course requirements. So there's going to be three different course requirements, three ways in which you're going to be assessed. The first one is what we call problem sets. So a problem set is basically a set of problems either taken from the textbook or ones that I've taken from other sources or ones that I've come up with myself that you then have to solve within 1 week. So at the last lecture of every week, I'm going to make a problem set available to you, and that problem set is going to be due exactly 1 week later. So for example, if the problem set 2 is handed out on Friday, January 20th, then it's due in class on Friday, January 27th. Now, there's going to be 9 problem sets in total, and only 7 of those will actually count towards your grade. So the 2 lowest scores that you get on a problem set will be dropped. And the idea behind a problem set is it's supposed to help strengthen your understanding of the material and also to prepare you for a short quiz that's going to happen the following week. Now, you're encouraged to work together on these problem sets. So you can ask each other questions. We can even work on them during class. So if we're going to be going over some practice problems and some exercises, and you have a particular question about one of the problems on one of the problem sets, we can talk about that during class as well. Now, I won't actually go over the exact solution for you because you should be doing that on your own, but during class time is the time to be asking questions about the problem set or if there's a particular question that you're struggling on. So, although you are encouraged to work together on it, and we are going to be working on parts of them in class, you are expected to hand in your own individual work. So, for example, suppose you get together with a group of 2 or 3 other people, you sit around on a blackboard, and one of you is actually writing down the solution to a particular problem. You guys are expected to put the solution into your own words, and then to be able to hand those parts in. Okay, and late problem sets will not be accepted. And the reason for that is because I'm going to be taking questions directly from the problem sets, and those are going to be turning up on the quizzes. And so this brings us to the second way in which you're going to be graded. So there's going to also be 9 quizzes in total, and 7 of those will count towards your grade. So the 2 lowest ones you'll be able to drop. And each quiz is going to consist of 1 or more questions that I take directly from the problem set up to the most current one. So what that means is so if we're on quiz 3, I can take a question anywhere from the problem set 1 up to problem set 3. Now for the most part, I'll be just quizzing you on questions that have been on the problem sets up to problem set 3, but every once in a while, if there's some parts that I think are extremely important, and I will remind you of this, I might take a question from an old problem set. And there should be no surprises here, right? I mean, I'm actually giving you the quiz, most of the quiz questions, before you even see the quiz. So if you're doing the work and keeping up with all the problem sets, and you're doing them for yourself, so after you've done and collaborated in a group, you go back and you make sure that you understood how the actual solution is supposed to go, then the quizzes will be a breeze for you for the most part. However, if you're sort of, just tagging along in a group, writing down exactly what they write down, come quiz time, you won't actually have understood how to do the solution, and then you won't do as well on the quizzes. So this is why it's really important to, although I encourage you to work together on the problem sets, you do need to make sure that you not only hand in your own work, but that you also make sure you understood it for yourself, because when it comes time to quizzes, you can no longer rely on the peers that you use to be able to help solve a particular solution. So each quiz, like I said, consists of 1 or more questions that are taken directly from one of the problem sets up to the most current one, but there will also possibly be 1 question related to the current week's problem set, but not taken directly from it. So I might change a few details and put that on the quiz to test whether or not you have in fact comprehended the material from that week. Now, each quiz will be given during the last lecture of the week after the current problem set has been submitted. So I said before that problem sets are going to be handed out on on the Friday, that means that the next Friday, the corresponding quiz for that problem set is going to take place during that lecture. So you can think about it like this. Every Friday, there's going to be two things. One, you have to hand in a problem set for that week. And two, there's going to be a quiz on that problem set on that Friday. And they won't take up the whole lecture. They'll just take up part of the lectures. Okay, and then the last requirement is the final exam. The final exam will be cumulative, and it will consist primarily of questions that we've already seen in the problem sets. So again, there aren't going to be any surprise. I'm not trying to surprise you guys, right? I'm going to be testing your comprehension, and your comprehension of the material is going to be sort of worked on during classes. So there's no surprises here. But nevertheless, it is going to be a challenging course, because what I'm going to be asking you to do is, for some of you at least, it might seem quite difficult, but we're going to spend lots of time practicing it. So the final exam is basically you get to show off all the practice that you did throughout the course. Okay, and then lastly, this is just sort of a skeletal structure of the schedule. So in week 1, we're just going to talk about the basic notions of logic and formal systems. So you just get a little bit familiar with what exactly it is that we're going to be doing in this class. And in the second week is when we're going to really start diving into the particular details of the logical system that we're going to study, which we call SL, which just stands for sentential logic. So we're going to talk about the syntax of the logic, the symbols that we use, and the logical operators for that logic. Then weeks 3 to 4 is we're going to talk about the semantics of SL, or sentential logic, and there we'll start talking about truth tables, and we'll use some of the tools that we learn in the semantics of SL to start talking about logical consequence, which I mentioned to you in the first video. Then weeks 5 to 6, we're going to spend a fair amount of time looking at the derivation system, SD, where SD just stands for sentential derivation. And so this is going to be a little bit closer to the kinds of arguments that we're going to be talking about in the first week, where you have a set of premises, and what you want to do is actually derive a conclusion. And this derivation system is going to help us understand what exactly this logical consequence relation that we're interested in that provides a grounding for what makes an argument a good argument and what makes some arguments bad arguments. Then in week 7, we're going to talk about an extension of SD, which is called SD+. And we're going to talk about some strategies for doing derivations, because derivations tend to be fairly difficult. In week 8, we're then going to talk about truth trees. These are much easier to do. Once we get through the derivation stuff, this stuff will seem like a breeze to you, so we won't need to spend nearly as much time on truth trees. And then the last 2 weeks, we're going to do some meta theory, where what we're going to do is start talking about this logical system and some of the interesting properties that it has. And yeah, so that's it for the course syllabus, and we'll see you in the next lecture.